Hey guys, today we're going to keep practicing solving word problems that use scientific notation, except there's going to be one little trick to it. Something that we need to cover is how you figure out how many times greater one number is than another. For example, if I said, how many times greater is 6 than 2? How many times greater is 6 than 2? What I'm actually asking is what could you multiply 2 by to equal 6? 2 times what equals 6? You guys all know this one. 2 times 3 equals 6. Therefore, 6 is 3 times greater than 2. Let's do another one. How many times greater is 10 than 5? Well, that's like asking 5 times what gives me 10? 5 times what gives me 10? Well, count by 5s. 5, 10. That's 2. 5 times 2 equals 10. So 10 is 2 times greater than 5. How many times greater is 100 than 2? So that's like saying 2 times what equals 100. As these numbers get bigger, it doesn't always make sense to say, okay, I'm going to count by 2s until I get to 100. But the good news is that if we need to figure out how many times greater one number is than another, we can actually divide to find that out. So let's go back to our first example of how many times greater is 6 than 2. Remember, we said that 6 is 3 times greater because 2 times 3 was 6. Another way I could do that is take this large number 6, divide it by 2, and that's going to tell me how many times greater 6 is than 2. 6 divided by 2 is 3. So 6 is 3 times greater than 2. Let's see if that works for the second one. How many times greater is 10 than 5? 10 divided by 5 is 2. And that's true. 10 is 2 times greater than 5. This last one. How many times greater is 100 than 2? I can take 100 divided by 2. 100 divided by 2 is 50, which means 2 times 50 equals 100, or 100 is 50 times greater than 2. You're probably wondering, where the heck am I going with all of this? Well, let me tell you. We're going to do this with scientific notation today. How many times greater is 8 times 10 to the 5th than 8 times 10 squared? Please make sure you have example 1, the line, and all of these words. Pause the video and make sure you have this. How many times greater is 8 times 10 to the 5th than 4 times 10 squared? Well, I definitely can't count by 4 times 10 squared to get to 8 times 10 to the 5th, so this is where I need to take my larger number and divide it by my smaller number. I know that this number is greater because it has a larger exponent. So I'm going to put this one on top of my division problem. 8 times 10 to the 5th divided by 4 times 10 squared. When we divide in scientific notation, you should remember from last week, we divide our coefficients. 8 divided by 4 equals 2. I'm always going to rewrite my times 10, and then this is just a MADS rule. When I multiply, I add my exponents. When I divide with a common base, I subtract. So I'm going to do 5 minus 2, which is 3. Therefore, 8 times 10 to the 5th is 2 times 10 to the 3rd times greater than 4 times 10 squared. That's not actually that helpful. So with these, you're always going to turn these back into standard notation. So let's pull out our coefficient 2, grab that invisible decimal, and I'm going to scoop 3 times to the right because this is a positive 3, and I want to make a number that's greater than 1. 1, 2, 3, drop off my decimal, fill in my zeros. Now I have an answer I can work with. I know that 8 times 10 to the 5th is 2,000 times greater than 4 times 10 squared. Let's do another one. Okay, please do not waste time copying down all these words. Write example 2, draw your line, and just be with me. The goose population is 2 times 10 squared. The duck population is 9.4 times 10 squared. How many times greater is the goose population than the duck population? Well, again, I'm not going to try to count by 2 times 10 squared to get to 9.4 times 10 squared. That would be really, really, really hard to do. I don't actually even know how to do that. So the way we solve this problem is we take our greater number and divide it by our smaller number. Take a look at these two numbers. I have 2 times 10 squared, and these are my geese. This is the goose population. And then I have 9.4 times 10 squared, and this is my duck population. In the last problem, I looked at my exponents to figure out which number was greater, but take a look. My exponents are the same. So when the exponents are the same, look at the coefficients. I have 2 and 9.4. This is $2, this is $9.40. This is the greater coefficient, so it's the number that's going to go on top. 9.4 times 10 squared divided by 2 times 10 squared. I'm not going to spend the time going over the division because I don't think this is actually the step you're going to struggle with. Let's take a look at one more example, and then it'll be your turn. Don't copy all this down. Please write example 3 and draw a line. In a survey of U.S. households, 1 times 10 to the 6th people answered that they own a bike. In the same survey, 4 times 10 to the 4th people answered that they own a skateboard. How many times greater is the population of bike owners than the population of skateboard owners? How many times greater is the population of bike owners than the population of skateboard owners? Let's go ahead and pull out those numbers. It says 1 times 10 to the 6th people own a bike. My pen is your pen. On your paper, you should have example 3, and then 1 times 10 to the 6th, and bike. Then it says 4 times 10 to the 4th people have a skateboard. To figure out how many times greater this number is than this number, I'm going to divide. If you weren't sure which one was the greater number, which one you're breaking up into smaller pieces, look at your exponents first. In 1 times 10 to the 6th, my exponent is a 6. Here, my exponent is a 4. This is my greater number, so it goes on top. 1 times 10 to the 6th divided by 4 times 10 to the 4th. Let's work this one out, then you're going to practice. When I divide my coefficients, this is 1 over 4. To divide, the first number is my dividend, the number that goes inside. The second number is my divisor, the number that goes outside. I'm breaking this one up into 4 equal pieces. I can't count by 4 to get to 1. 4, 8, 12, 16. It doesn't work. 1 is smaller. So I write 0 times. Then I'm going to break this one into tenths by adding a decimal and bringing it up. 4 goes into 10 tenths, or 4 goes into 10 2 times, because 4 times 2 is 8. I'm left with 2. I can't count by 4 to get to 2, and I'm out of numbers in my dividend, so I can add a 0 and bring it down. I can count by 4 5 times to get to 20. 4 times 5 is 20, so I'm done. My new coefficient is 0.25. Let's rewrite that over here. 0.25. But I'm not done because I want my answer in scientific notation, so I need to include times 10 to some exponent. Well, I'm dividing with a common base of 10, so I can just do 6 minus 4, which is 2. Something in your mind right now should be like, ooh, that's not right. And the reason why this isn't quite right is because it's not in scientific notation yet. It's not in scientific notation because 25 hundredths is less than 1. To make this a number that is greater than 1, I need to move my decimal once to the right. And anytime you're moving your decimal like this, I need you to call on your good friend Lars. When I move my decimal one step to the right, I need to subtract 1 from my exponent. So my final answer is 2.5 times 10. 2 minus 1 is 1. So that's my final answer. 2.5 times 10 to the first. Your turn to practice.